Hi friends, we're talking today about interior intersections and angles and arcs. Now, these are also called floating angles, and I want you to really get familiar with the vocabulary here. Just hit my camera. Get really excited about math. I want you to get real familiar with the vocabulary here. So, we know floating angles. The other ones I have conveniently written right here for you. Oh man, I thought I could have done so much better flipping that over. A floating angle, so you've already learned about central angles, which is from the center outward. Inscribed angle is on the circle and then goes outward. A floating angle does not go through the center. So it's just out there with where two lines cross. So that's the type of angle that we're talking about. And when we talk about those, there's neat things that go on with the segments and neat things that go on with the arcs and the angles. So the first rule that we're going to talk about is this one right here. So let's say you have a floating angle here and it does not go through the center. What we can do is take the measure of angle A here, the arc, and then the arc of B, add those together, divide by 2, and that will give us the measure of this angle right in here. So pause the video, write that down so you have it in your notebook. Now let's do a practice. Find the measure of angle DEC. Okay, so looking at this information here, what we have is, since we know this is 117 and 125, we know that, I'm gonna use blue so you can see this. I don't know why I had to announce that. 117 plus 125 divided by 2 equals. So if we do 117 plus 125 and divide that by 2, we end up with 121. That means this angle right here is 121 and this angle right here is 121 because remember, vertical angles are congruent and those vertical angles, they're across from each other like this. Now, if this is 121, what's this guy gotta be right here? Well, remember, this is 180 degrees because it's a line, right? So we take 180 and we minus 121 to get 59 degrees. So we now know this side right here is 59 degrees. And because that is 59, this one, because of vertical angles, is also 59 degrees. So the number one rule in geometry, always go back and reread the question. It says find the measure of DEC. DEC is this guy right in here, which we have determined is, so the measure of angle DEC, 59 degrees. 59 degrees. Okay, let's take a look at the next example that we have here. Same idea here. We got to find the measure of angle CED. But before we can do that, we have to figure out what X is. We got a couple things we can do here. The first thing I notice is, and so pause the video, give this a shot, knowing what you learned about this theorem, and see if you can do it. Keep in mind a little hint. A circle is 360 degrees. And why is that important? Because what I think we can do is, and it might help if you see these highlighted, plus I love the vibe of these highlighters. So the aesthetic is what's really getting there. We got this guy, we got this guy, we got this guy, and we got this guy, okay? Ooh, look at that aesthetic, love it. Okay, so we're gonna do 110 minus 2x plus, so this plus this plus this, plus x plus this, plus 275 minus 3x plus 2x. I don't think I missed anything there. All of that has to equal 360 degrees, okay? So let's simplify this as much as we can. I see a negative 2x and a positive 2x. Bam, bam, we're getting rid of that. I see x and negative 3x, so that's negative 2x. And then I see 110 and 275, which is 385. So plus 385 equals 360. All right, so if we minus 385 from both sides, we end up with minus 385 minus 385. We end up with negative 2x equals negative 25. Okay, now divide by negative 2. Divide by negative 2. We end up with x equals 12.5. Okay, so x equals 12.5. That's really helpful, except number one rule of geometry, always go back and reread the question. What is the measure of angle CED? Okay, just for the aesthetic and the vibes. CED is this guy right in here. CED. Well, gosh darn it, we do not have that information yet, so we have got some work to do. Let's see. What would be really helpful here is if we had each of these measures in degrees, each of these arcs in degrees, and we can do that because we now have x. So we know that this is going to be 12.5. We know 2x is going to be 25. We know this one over here, we're going to say 110 minus 2x, and 2x is 25. So we say 110 minus 25 is 85. And then this guy over here, 275 minus 3 times 12.5 gives us 237.5 for this guy down here. So we can get rid of these guys. Okay, so we are looking for CED, which means if we take this plus this and we divide it by 2, we're going to get CED right in here. So we say the measure of angle CED equals 25 plus 12.5. Divide that by 2 and we end up with 25 plus 12.5 gives us 37.5. And then if we divide that by 2, I made a mistake. Hold on one second. Do we want to find CED? Yes. Hold the phone. I did not make a mistake. I just don't know how to read. You'll notice I write the answers down here just to make sure that I don't mess up. And I was like, 59, what? Ah! So, but I did not mess up. We got 25 plus that, that's 37.5. Divide that by 2, and that will equal, conveniently it's written right here, 18.75. So we now know this angle right in here, it's super tiny, is 18.75 degrees. Okay, hopefully you found that helpful. If you have any questions, leave them below. Otherwise, we'll see you next time.